Ever get that zap from static? You know, like when you pull off a sweater? It's kind of wild when you think about it. That's basically mini lightning right there.
It really is. Everyday experiences like that give us a glimpse into these incredible forces of nature.
So true. And that's exactly what we're diving into today, lightning and earthquakes. We're taking a closer look at your source, CH12, some natural phenomena.pdf, to understand these events and how to stay safe.
It's fascinating how our understanding has evolved. I mean, the source even talks about how ancient cultures thought lightning was the wrath of gods.
I can only imagine what they must have thought. But seriously, what's going on with that static shock? Mini lightning bolts, for real.
You're closer than you think. It all comes down to charges, positive and negative ones. Everything has them, even us. And usually they're balanced. But rub certain things together, like a balloon and wool, and you change that balance.
Like the balloon steals something from the wool.
Exactly. The balloon grabs negative charges, leaving the wool with extra positive ones. And since opposites attract, the balloon wants to stick to anything positive.
Okay, so charges are moving around. But how does that turn into lightning bolts shooting across the sky?
Picture this. Inside a storm cloud, you've got all this wind and rain going crazy, creating friction. That friction acts just like rubbing a balloon on your hair. It separates those charges in the cloud.
Hold on, so the top and bottom of the cloud have different charges.
You got it. The top gets positive, the bottom gets negative. And that negative charge at the bottom is looking for a positive hookup. Sometimes it finds it in another cloud, but sometimes, boom, it connects with the ground and you get lightning.
So basically that crackle when you pull off a sweater, that's a mini lightning strike right next to you. Mind-blowing. And speaking of breakthroughs, what about Benjamin Franklin and his kite experiment?
Talk about a way to prove a point, right? Though it's wild how long it took for someone to make that connection.
Right. It makes you wonder about all the other mysteries waiting to be solved.
It really does. But hey, that's what makes these deep dives so fascinating, right? Discovering how these forces work and how we can stay safe.
Totally. Speaking of staying safe, let's talk about what to do during a thunderstorm.
The #1 rule is to find shelter fast. And I'm talking a sturdy building or a car, not a flimsy shed or anything like that.
So basically get inside and stay away from windows.
You got it. Windows are basically an open invitation for trouble if the wind picks up.
And it's not just about getting inside, right? There are things to avoid even if you're stuck outside.
Absolutely. Open fields, tall trees, water, basically. If you're the tallest thing around, you're in trouble.
So no hiding under a tree.
Definitely not.
Yeah.
And put that umbrella down. It's like holding up a sign that says, lightning over here.
Good point. Now, what about those lightning conductors you see on top of buildings? Those are designed to attract lightning, right? So how does that make things safer?
It's a clever trick, really. The conductor gives the lightning a direct path to the ground, kind of like a shortcut. It'd rather take that route than, say, fry your electronics.
Okay, that makes sense. So it's like redirecting the energy to a safe spot.
Exactly.
Yeah.
Now, we've talked about electrifying storms, but let's shift gears to the ground beneath us. Earthquakes can be just as powerful and often way harder to predict.
So true. We might get some warning signs with a thunderstorm, but earthquakes can hit with almost no notice. It makes you think about those recent earthquakes in India, like the one in Gujarat back in 2001.
Right, and that one was a 7.9 on the Richter scale. We'll get into what that means, but basically it was thousands of times stronger than a magnitude 4 quake. The impact on communities, the sheer destruction, it's a stark reminder of how important it is to understand these events.
Absolutely. So let's talk about what causes these tremors. What exactly is an earthquake? Is it really about the Earth balancing on a bull's horn, like some ancient myths say?
Well, our understanding has come a long way since then. The Earth on a bull's horn, it's a cool image, but thankfully not how it works. It's all about tectonic plates. Imagine the Earth's crust, the outermost layer, not as one solid piece, but like a giant jigsaw puzzle.
Okay, so you're saying the Earth's crust is broken up into these pieces.
Exactly. Each piece is a tectonic plate. And here's the thing, they're always moving, even if it's super slow. And where these plates meet, that's where things get interesting. They can grind against each other, push against each other, even try to slide under or over each other.
So there's a lot of pressure building up at those boundaries.
Exactly. And when that pressure finally gives way, bam, that's your earthquake. The Earth's crust shakes and trembles as those plates readjust.
I'm starting to see why predicting earthquakes is such a challenge. If these plates are always on the move, how can scientists know when and where that pressure will release?
It's a question that keeps scientists up at night. We understand the mechanics, but knowing the exact time and location is still really tough. It's kind of like trying to predict when a twig will snap. There are just too many factors deep within the Earth that we can't fully measure.
So while predicting earthquakes is still a work in progress, what tools do we have to understand and measure how powerful they are?
We use something called the Richter scale to measure the magnitude, or basically how much energy is released by an earthquake.
Yeah.
But here's where it gets interesting. The Richter scale isn't linear.
Meaning a 6 isn't twice as powerful as a 3.
Got it. A magnitude 6 earthquake is actually 1,000 times more powerful than a 3.
Wow, that puts things in perspective.
Exactly. And going back to the 2001 Gujarat earthquake, that one measured a 7.9. That's almost 10,000 times stronger than a magnitude 4 quake, which might feel like a strong jolt, but causes way less damage.
That's a massive difference. So we've got these huge plates causing earthquakes that we can't precisely predict, but at least we can measure their intensity. But how do we actually hear these events as they happen?
That's where seismographs come in. They're super sensitive instruments that can pick up even the tiniest vibrations in the ground caused by something called seismic waves.
Seismic waves are those like ripples from the earthquake?
Exactly. These waves travel through the Earth, and seismographs capture their every jiggle. By analyzing those recordings, scientists can figure out an earthquake's strength, location, even learn about the Earth's interior.
It's amazing that even if we can't always predict earthquakes, we can use technology to understand them better, maybe even reduce the risks. Speaking of reducing risks, what are the most important things people should know about staying safe during an earthquake, especially in earthquake-prone areas?
It all starts with being prepared. Think of it like a fire drill. You don't wait for a fire to start practicing your escape route. Same goes for earthquakes. If you're inside when an earthquake hits, remember, drop, cover, and hold on.
Drop, cover, and hold on. Sounds simple enough, but what does that look like in practice?
It's about finding a sturdy spot and protecting yourself from falling objects. Get under a desk or a table, stay away from windows or anything that could shatter. Make yourself small and hold on tight until the shaking stops.
So if you're under a table, it's like you're making your own little safe space. But what if you're outside when an earthquake hits? That seems way more scary.
Yeah, being outside definitely adds a different layer of concern. That's when finding a clear spot is super important. You don't want to be anywhere near buildings, trees, power lines, anything that could come crashing down.
Yeah.
Getting to an open area, if you can do it safely, that's your best bet.
And if you're already in a car when it hits?
Stay put. If you're driving, pull over somewhere safe, away from overpasses or bridges, anything that could be damaged, and just wait it out in the car.
Like that's your little mobile safe zone.
Exactly.
It seems like staying calm and figuring out your surroundings quickly and safely, that's key.
You got it. And it's not just about knowing what to do during the earthquake, but also being prepared beforehand, just in case.
Right, like having a plan makes a difference.
Huge difference. It's like, talk to your family about what to do if an earthquake hits. Where will you meet up? Who should you try to call? Just having those conversations ahead of time can really help if it actually happens. You're not scrambling, trying to figure things out when you're already stressed.
That makes a lot of sense. Knowing what to expect can make a stressful situation a little less scary. And it's pretty cool the source mentions that there's this place, the Central Building Research Institute in Roorkee, and they've actually developed technology to make earthquake-resistant houses. How amazing is that?
Oh yeah, that's some seriously impressive stuff. They're putting our understanding of earthquakes into action, finding solutions to make buildings safer. Think about it. What if entire cities, especially those in high-risk areas, were designed using those techniques?
That would be game-changing. Building structures that can withstand those kinds of forces, it could save so many lives.
Exactly. It really shows that we can't control nature, but we can definitely use our knowledge to adapt and create a safer world.
This has been such a fascinating look at natural phenomena. It's amazing. From tiny static shocks to powerful earthquakes. There's so much to learn about the world around us,
Absolutely. And it just goes to show everything is connected. The same forces that make a crackling sound when you take off a sweater are also at work in these huge events like lightning and earthquakes.
It really makes you think understanding these forces is one thing, but knowing how to stay safe and build a better, stronger future, that's where the real power is.
I couldn't agree more.
Well, that's all the time we have for today's deep dive. Thanks for joining us.